So in this video we're going to go through an example question that will help you understand more about when you should use the sine rule or the cosine rule. So this is our triangle that's been given to us, and it's asking us to find the angle ABC, and that's this angle here in the corner. So I've just redrawn the triangle so that it's a bit more clearer for us. And then if we look at our two equations, for the cosine rule you need to know A, B and C, the lengths, all of the lengths in the triangle. But if we look at our example, we only have two of the lengths, so we know that we can't use this rule just yet. And then for the sine rule, you need to know an angle A and its opposite length A. And then you also need to know either an angle or a length. So if we look at our triangle, we've got this angle here and we know the opposite length as well. And we also have this length here, so that means that we can find out the angle opposite, which is C. So we're going to do that. So sine of C divided by its opposite length, which is 5, is equal to sine of another angle, 0.6. Make sure you calculate in radians for this. Divided by its opposite length, which is 4 centimetres. Then we're trying to get sine of C on its own, so we just have to times this 5 by both sides. So bring this 5 up to here. So that's sine of C equals 5 sine of 0.6 divided by 4. And then when you have sine of an angle, to get that angle on its own, you have to do inverse sine of this fraction right here. So sine minus 1 of all of this fraction here is 5 sine 0.6 divided by 4 is equal to your angle C. And that gives us an answer of 0.783556 radians. Notice how I've left this angle to as many significant figures as possible, because that's not our final answer. We're looking for this angle B and we've just found C. So you can round later on when you get your answer for B. So for now I'm just going to put this into our diagram. So C is 0.783556 radians. Then finally, to find the remaining angle B, we don't have to use either of these rules, they're a bit more complicated. We can just use our basic knowledge of triangles, which is the angles in a triangle add up to 180 degrees. But remember, we've just found our answer for the angle in radians. So we have to think about what 180 degrees is in radians, and we know that's pi radians. So if all the angles in a triangle add up to pi radians, and we have two of our other angles, we just have to do pi, take away 0.783556, take away 0.6, and that will give us our angle B. So we get an answer of B equals 1.76 radians. And that's when you round it, and that's our final answer.